We are. Alrighty, when we broke for lunch, we had heard all of Dr. Schnarr's testimony. Mr. Tremaine, would you call your next witness?
Thank you, Madam Hearing Officer. The OCD calls the Engineering Bureau Chief, Justin Wrinkle.
Mr. Wrinkle, would you please spell your first and last name?
Yes, Justin Wrinkle, Justin Wrinkle.
Do you swear or affirm to tell the truth?
I do.
Thank you. Go ahead.
Thank you, Madam Hearing Officer. I have already started sharing screen to work through these exhibits. Mr. Wrinkle, you are currently employed by the Oil Conservation Division, correct?
Correct.
What is your position or title with the OCD?
Engineering Bureau Chief.
Great. And did you prepare direct written testimony in preparation for this hearing today?
I did.
And is that what is marked as OCD Exhibit Number 4?
Yes.
Okay. Are there any corrections that you need to make to your direct testimony this morning?
Yes, one small clarification. I don't recall what part it is. It's in the beginning where it asks if I have testified before. Yeah, right there. Have you previously testified in state or federal regulatory proceedings? And what is wrong there is the technical and fact witnesses are swapped. I should have been a fact witness in a adjudication and a technical witness in a rulemaking.
Thank you. No other corrections to your direct testimony?
No.
And do you adopt your direct testimony as your sworn testimony today?
I do.
Okay. Moving on, Mr. Wrinkle, did you prepare a resume in preparation for this hearing marked as OCD Exhibit 5?
I did.
And is that resume true and accurate to the best of your knowledge?
Yes, it is.
Okay. Mr. Wrinkle, I'm going to show you what is labeled as OCD Exhibit Number 17. Mr. Wrinkle, what is Exhibit 17?
It's a very, very high level holistic view of what is reviewed in a Class 6 permit before it becomes a draft permit.
Similar to the flow chart presented by Dr. Schnarr, is this a representation of OCD's workflow and process?
Correct, yeah. So the current Class 6 team is developing a New Mexico flow chart based off of the implementation manual from the EPA, and this is a product of that.
And did your team prepare this slide or exhibit?
Yes, they did.
Okay, thank you. One more question on these. Mr. Wrinkle, did you prepare pre-filed written rebuttal testimony in preparation for the hearing today?
I did.
Okay, and are there any corrections or changes necessary for your rebuttal testimony?
No.
Okay, and do you adopt your rebuttal testimony as your sworn testimony, sworn rebuttal testimony today?
I do.
Okay. Madam Hearing Officer, I would move admission of exhibits 4, 5, 17, and 21 before we proceed.
Thank you. I'll pause for a moment in the event any other party would like to object. Thank you. 4, 5, 17, and 21 are admitted.
Thank you, Madam Hearing Officer. Mr. Wrinkle, are you prepared to provide a less than 1 hour summary of your direct testimony for the commission today?
I am.
Please proceed.
Okay, and just so you know, I'll be working off some notes here that just bulleted parts of my direct. You know, they're available to anybody if they need them. So the purpose of my testimony was basically to demonstrate the OCD's readiness, staffing structure, technical capability, and basically the stability to administer the Class 6 once we receive primacy. So our regulatory strength and capability is, you know, we do have an EPA approved Class 2 program since about 1982, which is actually the year I was born. So pretty long time that we've been administering that. We already have established systems for permitting, inspections enforcement, and data management. So it's nothing new. We have existing regulatory framework provide a stable foundation for implementation the Class 6 program. To go into a little bit of detail about what I touched on with staffing and full-time employees, there is 3 full-time employees currently that are just for the Class 6 program. We have 1 supervisor that is a senior geologist, 25 years experience. We got one of the technical staff comes from a sistering state, I believe the Railroad Commission. Petroleum engineer. And then we also have just given an offer to an individual that currently works at the Railroad Commission in their Class 6 program with a PhD in petroleum science, and he should be starting in September. It doesn't end there. The way that our Bureau works is basically we rely on all aspects of engineering. If there's somebody that has a certain particular skill or history, we can reach out and lean on them. Currently, I believe engineering as a whole has about 45 individuals in it that are come from a very diverse background and specialize in different things. For the more complex things, as I talked about in my testimony, we do have the ability to retain specialized contractors specifically for model vetting and those type of things if we feel the need to. To touch on funding source and program stability, so all 3 of these positions are permanent positions rather than any term positions. They are funded directly by the general fund, and I did notate the contract services are supported through existing funding, i.e. the general fund, plus any supplemental grants when available. So we know that those aren't guaranteed, i.e. that's why it's supplemental. It'd be good if we had that funding to utilize, but most everything is going to be funded through the general fund. Technical readiness. So we'll utilize systems already in place for other permits, ensuring consistent application of permitting, review, monitoring, and enforcement standards. The EPA implementation manual for Class 6 program managers has given us a extremely well plotted out avenue for how to conduct our permitting. When we do get primacy, and then when there is a final promulgated rule, it's allowed us to pinpoint where New Mexico is going to be more stringent and kind of draw our own path from there, to not deviate from the implementation manual, but basically add to, right? Because there's things that New Mexico is going to be doing that are more stringent than the EPA, so we have to build out those flow paths for our procedural needs. And then, of course, again, internal staff can be supported by specialized contractors to ensure, all the coverage across geology, engineering, geomechanics, and data analysis. Our digital systems that we already maintain statewide handles thousands and thousands and thousands of documents and permits and applications and sundries. So we're, more than ready to, take on that data burden, as you would say. The financial assurance and USDW protection. These FA requirements ensure that funds are available for corrective action, as Dr. Schnarr was outlining in his corrective action, emergency response, any plugging, site closure, and post-injection site care. So this ensures long-term of protection of underground drinking water, because those funds would be available if needed, if the operator was unwilling or unable to do so. And that is really my demonstrative for my testimony. I know I blew right through that, but I apologize.
I'd like to ask you a clarifying question, Mr. Wrinkle. So we've heard earlier a question of the clarity around the positions. Can you just clarify for the parties and the commission which of the positions you outlined are already filled and which are to be filled?
Yeah, so the supervisor of the Class 6 program that reports directly to me, that's filled already. And then one of the petroleum specialists that report to him has been filled. The other one starts September 12th of this year.
Okay. So as of September of this year, all 3 dedicated positions will be filled with full-time staff.
Correct, yes.
And those staff are dedicated solely to or directly for future Class 6 permit review and other related work?
Correct.
Okay. And the 2 staff that are already in place, that they participate, are they already engaged in preparing and developing the permit review program?
Yes, they are. They're actually quite a ways into it, and have been meeting with organizations like the Groundwater Protection Council, have showed them, our current progress, and they say that, it's their opinion, right? But they say that we're a lot further ahead than most other states were at this point.
Mr. Wrinkle, are you prepared to provide a brief summary of your rebuttal testimony today?
Yes, I am.
Please summarize your rebuttal testimony for the commission.
Okay, do you want me to just summarize the findings of mine, or do you want to, are we looking at what I am rebutting?
No, just provide your prepared summary for the commission of your rebuttal, your written rebuttal testimony.
Okay. So just go over the response then. Sorry, travel day.
Yes.
Okay. All right. So, my response to what my rebuttal was, basically the division already has an established functioning appeals process under 1915-48 MNAC. This process will continue to apply to Class 6 permitting decisions. So as I was preparing my rebuttal, I consulted with our division leaderships, and including the ones that are responsible for hearing procedures. We collectively agreed that the current process is effective, fully functional, and that adding an appeals process to Class 6 wouldn't add any value or anything to the new rule.
So is it the division's position that in the event an applicant appeals a permitting decision, that that application and hearing process would proceed according to the existing adjudication rules?
Yes, correct. That there already was a determined path there for anybody that wanted to appeal.
Thank you. No further questions.
Okay.
Okay, thank you, Mr. Tremaine and Mr. Wrinkle.
Madam Hearing Officer, the Oil Conservation Division calls Dr. Sai Wong.
Hello, Dr. Wong. Would you spell your first and last name, please?
First name is S-A-I. My first name is S-A-I, last name is W-A-N-G, Wong.
Thank you. Do you swear or affirm to tell the truth?
Could you please repeat?
Thank you. Go ahead.
Point of.
Do you swear or affirm to tell the truth?
Yes, I do.
Thank you. Go ahead.
Okay. Good afternoon, Dr. Wong. Thank you. Dr. Wong, what is your current position and title with New Mexico Tech?
I'm an employee at New Mexico Tech. I'm serve as an assistant professor for the petroleum department, and also I'm leading a group for Petroleum Recovery Research Center at New Mexico Tech right now.
Okay. And are you engaged in this process as an employee of New Mexico Tech to support OCD's application for Class 6 primacy?
Yes, I do.
And are you testifying today on behalf of the Oil Conservation Division as a technical witness?
Yes.
Okay. Dr. Wong, have you prepared direct testimony, pre-filed written direct testimony labeled as OCD Exhibit number 10?
Yes, I did.
I will share screen again. Show that. Dr. Wong, does your pre-filed written direct testimony require any corrections or changes today?
No.
And do you adopt your pre-filed written direct testimony as your sworn direct testimony today?
Yes.
Okay. Dr. Wong, have you also prepared a resume outlining your experience and qualifications labeled OCD Exhibit number 11?
Yes, that's correct.
And does that Exhibit 11 require any corrections or changes today?
No.
Dr. Wong, did you also prepare pre-filed written rebuttal testimony labeled as OCD Exhibit number 24?
Yes.
And does this exhibit require any corrections or changes?
No.
Okay. And do you adopt your pre-filed written rebuttal testimony as your sworn rebuttal testimony today?
Yes.
Okay. Thank you. Madam Hearing Officer, I would move admission of Exhibits 10, 11, and 24.
I'll pause for a moment in the event there are objections. Exhibits 10, 11, and 24 are admitted.
Dr. Wong, have you prepared a demonstrative exhibit to facilitate the summary of your direct testimony for the commission today?
Yes, I did.
Okay, and are you prepared to proceed? Are you prepared to present the summary of your testimony for the commission?
Yes, I do.
Okay. One moment. Sorry about that. All right. Dr. Wong, please proceed.
All right. Thank you, Jesse. Good afternoon. My name is Sai Wong. I'm a assistant professor from New Mexico Institute of Mining and Technology, and short-term AMT. And also, I'm a section head for Petroleum Recovery Research Center at the New Mexico Tech at the same time. So I today please go back to the previous one. Yeah. Today I'm gonna my testimony gonna cover two portions: the 15.42, 19, the section H, and section M. Section H is about the logging, testing, and the sampling prior to the well construction, and then the section M is for the well plugging. Okay. Next slide, please. So I got my master's degree from New Mexico Tech with a major of petroleum engineering, and also I'm holding a PhD degree from University of North Dakota. After that, with the same major, petroleum engineering. After that, I was hired as a field engineer, which focused on the field operation in EERC at University of North Dakota. So I have a bunch of experience with the federal CCUS projects. I was served as the co-PI key personnel for the Department of Energy carbon save programs in New Mexico, in Utah, and Texas, and North Dakota. Okay, so my main research was focused on the well design, well drilling, well completion, and well bore integrity. Okay, so I also familiar with well logs and reservoir characterizations and the geochemistry aspects for the well class 6 well construction. Okay, please next slide. So when we start this kind of class 6 project, the first thing we're going to consider as an operator is we need to perform the set characterization in detail to make sure the set is proper for the CO2 storage permanently. Okay, so the purpose for the pre-injection characterization right here is to verify the reservoir and the confining zone, the suitability of these two major zones. Okay, and then also same time with this kind of injection characterization effort, the operator shall be able to establish the baseline geological and geochemical conditions of the data from this well test, from the logging programs, from the sampling programs. Okay, and we also the operator shall be very clear to ensure the well construction conforms with the Class 6 requirements. For example, when we get the well logging program performed, we get the gamma ray logs data, so that logging suite gonna give you some information for the formation tops. Then based on the formation tops, you can do the well design and what's the casing materials you're gonna select and the length and how many joints you're gonna select for this well design. Okay, and those kind of like efforts gonna reduce the uncertainty before the CO2 injection. Next slide, please. Okay. Under the 19.15.43.9 section H, the logging, sampling, and testing prior to the injection well operation, there are several required characterization efforts need to be performed by the operator. So the operator shall perform the following efforts to confirm the formation depths and the thickness, and also the lithology. What is the lithology for the injection zone and cap rock? For example, the injection zone, it's gonna be sandstone or limestone. It depends. Okay, so this kind of like logging effort gonna give you the firm answer on the formation lithology. Okay. Also, we need the porosity and permeability. Basically, the porosity property of the formation can be acquired from the direct logging effort. So we have the porosity logs that can be performed through the wellbore, through the open hole wellbore, and alternatively, we can link the porosity to some geophysical correlations to get the permeability data from the porosity. So these two parameters are very important for the CO2 storage capacity estimation in the modeling. So when we know this porosity means the space for the CO2 fluid or stream gonna occupy in the reservoir. Okay, what's the possibility that the CO2 can occupy those kind of empty space or void space in the reservoir? So porosity gonna give you a firm answer on those. And also the operator shall confirm the formation fluid salinity. From the EPA Class 6 program, there is a clear definition on the USDW. So through these well logging programs and sampling programs, they definitely gonna give you a clear answer on the fluid salinity. Is that gonna define as a potential USDW or is not? Okay, and all of those characterization gonna be formed a baseline data for the future comparison after several years injection for the testing and monitoring plan. Okay, so those kind of data can be compared with the initial data and see if there's any property alternation through the injection or post the injection, and how to evaluate this kind of alternation. Okay, and as an engineering objective, those kind of required characterization can demonstrate the suitability of the storage system for Class 6 project in New Mexico. Okay, the required logging program under the 15.43.9 section H, including the pre-casing logs, the gamma ray, resistivity, spawns, SP logs, caliper, and porosity for the surface casing, intermediate casing, and production casing. And the fracture finder logs are specifically for the long string casing portion. Okay. After the casing installed or placed, the operator shall also perform the post-casing logging program, including the cement bond logs, variable density logs, and temperature logs. Those three combination, CBL, VDL, and temperature logs, gonna give you a firm information or solid information to evaluate the cement bond between the casing and the formation, and between casing Okay, all those free channels that has the cement installed or placed. Next slide, please. So besides the logging portion, the operator shall also perform the mechanical integrity verification. The purpose for this verification is to verify or prove the internal and external mechanical integrity. During the well construction phase, so there's always some engineering issue happened when we place the casing. So for example, the over-torqued through the coupling or connections, there's going to be a potential leakage portion for the through the CO2 injection. So this kind of mechanical integrity verification gonna justify those potential leakage as a pathway for the CO2 fluid internally through the tubing and through the casing. Okay, and also this mechanical integrity verification can confirm the zonal isolation and prevent an unintended fluid mitigation upward. So the proposed methods under this program, including the pressure test through the casing, the tracer survey to identify any unforeseen leakage through those well construction elements, and temperature noise logs, and also casing inspection logs. Okay, next slide, please. So under this section, the last portion is about the cement evaluation. So cement is very important. It's a very critical barrier for the wellbore integrity. Okay, so the operator shall perform the cement evaluation to identify the cement quality. Okay. You can see on the right side of there is an image on the cement bond. That's the radio map on the cement quality. Okay, the dark portion means we have a good cement bond right there. The yellowish color means there is some potential channel within the cement. Okay, so there's a criteria from industry, from the rules to identify the cement bond quality. Okay, so those kind of evaluation can help the operator to further do the remediation, and those kind of good cement provides the hydraulic isolation. If we have poor cement, then may create a pathway for the fluid migration. Sorry. So again, the cement bond variable density and the temperature logs verify the cement quality before the injection. Next slide, please. Excuse me. So the last portion under my testimony is the 19.15.43.9 section M, the injection well plugging. After we complete the injection, we cease the operation. There's a need for the operator to plug the well permanently. The purpose for plugging the well is to provide the protection continuous after the injection. And also these well plugs is the final engineered barriers, because after you complete the operator finish the injection, the fluid is mainly from the tubing, and then you pull out the tubing, and then the well plugs, the placement should be there and must be there to provide a final barrier for the entire wellbore. So from the reservoir to casing, this connection portion we have cement placed. So the injection zone from the bottom hole to the wellhead, there also need a plug, a barrier. That's the well plugs. And besides that, some other mechanical barriers also going to be included, like the bridge plugs and some other techniques can be applied. Okay, So the well plugging, injection well plugging program requirements include 3 steps. First, when the operator shall flush the buffer with the buffer fluid to remove any existing CO2 stream in the well ball and near the well ball. And then the operator shall perform the pressure test to measure the bottom pressure and also perform the final external mechanical integrity test for the well ball. Okay. In the plugging plans should include the pressure and the mechanical integrity test, the plan for that one, the procedure for, of the MIT, and the procedure to remove the casing and tubing, and plugging placement design, how many plugs, what's the materials you're gonna utilize, and the cement formula for the compatibility consideration with the casing with the formation. Okay. Also, the well plugging schematic should be shall be included in the plugging plan. Next slide, please. So, to summarize, so my testimony covers the 2 portions, section H and section M on the logging, sampling, and coring testing prior for the well construction, and also the well injection well plugging. So all of those rules that we proposed gonna provide a comprehensive characterization that gonna reduce the uncertainty for the Class 6 project in New Mexico. All those kind of logging suit we proposed in this under these sections gonna verify the well construction, and the mechanical integrity testing confirms the containment. Okay, proper plugging protects the USDW. Okay, the proposed rules from applicants support safe and science-based Class 6 operation. Yeah. Next slide, please. Here's some reference I quoted for this presentation, including these 2 sections under the 19.15.43.9, and also from the federal, the EPA Class 6 program, the 40 CFR Part 146, subpart H, and 40 CFR 144.12. Also, the EPA Class 6 guidance gave me some reference to prepare these slides, and some Department of Energy carbon safe best practice manual. That's all from my presentation. Thank you.
Are you prepared to provide a summary of your rebuttal, pre-operating rebuttal testimony?
Yes.
Please proceed. Please proceed.
So I have one rebuttal testimony from conversation about the testing and monitoring program. So they were, let me check the statement right here. From the conservation groups to prescribe implementation details that are already addressed through the project-specific testing and monitoring program. So in my opinion, the language currently contained in 40 CFR 146.9 and OCD's proposed rules is sufficient to establish the operational requirements for conducting testing and monitoring during the Class 6 injection operations. So retain this existing proposed regulation language while relying on the project-specific testing and monitoring plans provides sufficient flexibility to address set specific operational conditions without imposing additional statewide requirements that may be unnecessary or redundant. So I disagreed with the the request from conservation groups on that rebuttal testimony. That's all I have.
Thank you. Madam Hearing Officer, I have one rebuttal question.
Please go ahead.
So, Dr. Wong, have you reviewed the rebuttal testimony submitted by the conservation groups related to spontaneous potential?
Yes, I did.
Okay. In the conservation group's rebuttal testimony, what's labeled as CG-476, the conservation groups are responding to Dr. Harvey Oxy's witness and supporting inclusion of spontaneous potential in the requirements. Do you agree with that characterization?
I agree, yes.
Okay. So we've heard in Oxy's direct testimony the proposal to remove spontaneous potential, and in conservation group's rebuttal testimony, the recommendation to include it. Dr. Wong, how do you respond to that testimony?
So the request from Oxy to remove the SP logs is objective to the EPA Class 6 rules under 40 CFR 146. So from there, the SP logs is required for surface section, intermediate section, and production section for the long string section. Yeah, same time. So SP logs also, from the technical point of view, SP logs is also very important to assess the gamma ray and some lithology and some other logs to identify the lithology and provide some information on the residue water saturation for the formation. So based on those observations, I will not agree with Oxy's proposed request on the SP logs.
So just to sum up, Dr. Wong, if the commission removed spontaneous potential logs as proposed by Oxy, is it your opinion that the rule promulgated by the commission would be less stringent than the EPA rule?
Yes, I agree.
Okay. Is it your opinion that spontaneous potential logs should be included?
It should be, yes.
Thank you. No further questions.
Thank you, Mr. Tremaine and Dr. Wong.
Thank you all.
All right, Madam Hearing Officer, we are moving right along quite expeditiously. So our next witness is Mr. Matt Eales.
Thank you. Mr. Eales, would you spell your first and last name, please?
M-A-T-T, last name E-A-L-E-S.
Do you swear or affirm to tell the truth?
Yes.
Thank you.
Good afternoon, Mr. Eales. Where are you currently employed and what is your title?
Currently employed at Cool Sky Energy Solutions as President and CEO.
All right, and are you working as a subcontractor with the New Mexico Institute of Mining and Technology to support OCD's application for Class 6 primacy?
Yes.
Okay. And are you testifying today on behalf of the Oil Conservation Division as a technical witness in this rulemaking?
Yes.
Thank you. Mr. Eales, have you prepared direct pre-filed written testimony in preparation for this hearing marked as OCD Exhibit number 12?
Yes, I have.
All right. Does that testimony require any changes or corrections today?
No, it's correct.
And do you adopt your pre-filed written direct testimony as your sworn testimony today?
Yes.
Okay. Did you also prepare a resume marked as OCD exhibit number 13, outlining your experience and qualifications.
Yes, I did.
Is this true and accurate?
Yes, it is.
Okay. Did you also prepare pre-filed pre-filed written rebuttal testimony marked as OCD exhibit number 25?
Yes, I did.
Okay. And does the pre-filed rebuttal testimony require any corrections or changes today?
Yes, I recommend a correction on the request from CBD to include CAPROC assessment for a conversion from a 2 to 6, in line with Dr. Schnarr's point. It's a good point to raise that, but I would just change it from CAPROC to confining zone, as referenced earlier.
So to clarify, in your rebuttal testimony, you indicated that you would testify that you rejected the proposed change. Is that correct?
That's correct.
With the language proposal provided by Dr. Schnarr, you now support that change?
Yes.
Thank you. Are you prepared to, or do you adopt your pre-filed written rebuttal testimony as your sworn rebuttal testimony today?
Yes.
Okay. Madam Hearing Officer, I would move admission of exhibits 12, 13, and 25.
I'll pause for a moment in the event another party has an objection. 12, 13, and 25 are admitted.
Thank you. Mr. Eales, have you prepared a demonstrative exhibit to facilitate providing the summary of your direct testimony for the commission today?
Yes, I have.
All right. Is that the demonstrative that I have on the screen right now?
Yes.
All right. Please proceed with your summary of your direct testimony and let me know if you need to change slides.
Okay, change slides, please. Just a history on education and experience. Went to University of Kansas, got a degree in Master of Science in Environmental Engineering. I've had 28 years of experience in various global oil field operations for Schlumberger, Smith International, primarily in the environmental health, safety, and regulatory compliance arenas. Specialize now in technical support for Class 2 UIC acid gas injection well permitting operations and compliance. Continue to participate in several work groups within the American Petroleum Institute, Society of Petroleum Engineers, International Oil and Gas Professionals, and then the Groundwater Protection Council, all related to injection control UIC. Same area, environmental health and safety. In the last few years, I've worked with a greater team to develop 10 EPA-approved MRV plans, which define operational requirements or monitoring requirements for CO2 injection operations. Next, please. So the purpose of my testimony is to provide technical support to the OCD for the proposed adoption of 19, 15, 41, 42, and 43 as part of the New Mexico's application for Class 6 UIC primacy. In general, I'll be addressing the technical and regulatory compliance requirements that are applicable to Class 6 wells, and that's including the construction, operation, and then safeguards for USDWs. More specifically, I'll be getting into detail related to injection well construction requirements, operating requirements, mechanical integrity, testing and monitoring, reporting requirements, and emergency and remedial response. Next, please. So starting with construction requirements, we've touched on a lot of those points today, but getting into the details, the Class 6 regulation regulates the design of the well with a general goal of ensuring wells are constructed and completed to prevent movement of fluids in or between USDWs or any other unauthorized zones. They permit the use of testing devices and workover tools and permit continuous monitoring of the annulus space between the injection tubing and the long string casing. It also regulates casing and cementing of Class 6 wells, including the requirement that casing and cement or other materials used in the construction have structural strength and be designed for the life of the project. It includes the requirement for surface casing for all Class 6 wells, that they be set and cemented through the base of the deepest known USDW aquifer, and must extend into an underlying confining unit. In addition, it requires that at least one long string casing using a sufficient number of centralizers must extend to the injection zone. And then continue on to the next page, please. Specific to cement and cement additives are required to be compatible with the carbon dioxide stream and formation fluids. They have to be of quality and quantity to maintain integrity over the design life of that well. So considerations to do that include depth to injection zone, injection pressure, external and internal pressure, hole size and grade of all casing strings, corrosiveness of the carbon dioxide string, downhole temps, lithology of the injection and confining zone, specified cement type or grade, quantity, and composition and temperature of the CO2 stream. In addition, tubing and packer requirements are specific, and they have to include construction compatibility to the injectate fluid and the appropriate packer depth. Operators are required to submit the planned setting depth, characteristics of their CO2, maximum proposed injection pressure, maximum proposed annular pressure, proposed injection rate, size of tubing and casing, as well as the tubing tensile, burst, and collapse strengths. Next. So moving on to well integrity requirements. Within this section, the operator is required to perform an initial annulus pressure test, continuously monitor injection pressure, rate, injected volumes, and pressure on the annulus between the tubing and the long string casing, as well as track the annulus fluid volume. At least once per year, the operator must use one of the following methods to determine the absence of fluid movement, and that can either be an approved tracer survey or a temperature or noise log. The operator may also be required to perform a casing inspection log. So maintaining well integrity ensures that the casing, cement, and tubing continues to prevent moving of fluids into or between the USDWs or other unauthorized zones. So next, please. So within the emergency and remedial response plan section of the proposed rule, an emergency event is defined as any event in which movement of the injection or formation fluids may cause an endangerment to a USDW during construction, operation, and post-injection site care. The proposed program requires that operators maintain and implement an approved plan which is directly enforceable regardless of whether the requirement is a condition of the permit. The operator must conduct outreach with communities within the AOR or area of review during the development of that plan. This outreach must identify the chain of command for notifying the public in the event of an emergency and incorporate this information in the plan, as well as develop protocols for notifying the public about well-related issues and/or emergencies. The operator must provide that training for local emergency responders and include a summary of community outreach activities prior to the plan submittal. Next, please. Along the same route of emergency response, if the operator obtains evidence that the injected carbon dioxide stream and associated pressure front may cause endangerment to a USDW, they must immediately cease injection. Take all steps reasonably necessary to identify and characterize any release, notify the director in 24 hours, and implement the emergency and remedial response plan. The program can require additional monitoring, testing, or corrective action in response to emergency conditions. And the operator would be required at that point to revise its emergency and remedial response plan and include additional monitoring requirements. The proposed program can modify operations or require shutdown of injection activities if it deems the injection is a risk to a USDW. Next, please. So Class 6 AOR meaning and monitoring purpose. AOR is defined as the area surrounding an injection well, described according to the criteria set in 40 CFR 14606. Or in the case of an area permit, is the project area plus circumscribed area, the width of which is either a quarter mile or a number calculated according to 40 CFR 14606. More specifically, it's the region surrounding the geologic sequestration project where USDWs may be endangered by injection activity. The purpose for monitoring is to ensure compliance with the standards which requires no operator shall construct, operate, maintain, convert, plug, abandon, or conduct any other injection activity in a manner that allows movement of fluid containing any contaminant into drinking water. Next, please. So the monitoring requirements from the program include the following. Operators are required to perform an analysis of the carbon dioxide stream with sufficient frequency to yield data representative of chemical and physical characteristics. They're also required to install and use during workovers continuous recording devices to monitor pressure, rate, volume, as well as the pressure on the annulus between the tubing and the long stream casing, and the annulus fluid volume added. Corrosion monitoring of the well materials must be performed on a quarterly basis to ensure the well components meet the minimum standard for material strength and performance. Quarterly monitoring of the groundwater quality and geochemical changes above the zone that may be a result of CO2 movement through the zone is also required. A demonstration of external mechanical integrity is required at least once per year. Pressure fall-off test at least once every 5 years. Testing and monitoring to track the extent of the plume and the pressure or absence of elevated pressure is also required. And then finally, seismicity monitoring is required as part of the operational and post-injection program. Next, please. So the operational pressure, one of the key points is the operator must ensure that the injection pressure does not exceed 90% of the fracture pressure of the injection zone. That ensures the injection does not initiate new fractures or propagate existing fractures into the injection zone. In no case may injection pressure initiate fractures or cause movement of fluids that endangers the USDW. This is achieved through a number of operational requirements, including prohibition of injection between outermost casing, protecting USDWs, and the well bore, monitoring the annulus between the tubing and the casing, long stream casing, maintenance of mechanical integrity, and several other monitoring requirements. Next. So pressure protection, it's required to ensure that the injection pressure remains below that point that I raised earlier. So it's still protective of the confining zone. It's defined as the geological formation. The confining zone is defined as a geological formation, group of formations, or part of the formation that's capable of limiting fluid movement above the injection zone through a number of means. So one, during the construction of the well, the program requires the operator take whole cores or sidewall cores of the injection zone and the confining system and formation fluid samples for the injection zone. Operator must also submit a detailed report prepared by a log analyst that includes well log analyses, including the well logs, core analyses, and formation fluid sample information. Operator must also record the fluid temperature, pH, conductivity, reservoir pressure, and static fluid level of the injection zone. Operator must also calculate the following information: fracture pressure, other physical characteristics and chemical characteristics of the injection and confining zone, physical and chemical characteristics of the formation fluids in the injection zone. And upon completion, the operator must conduct a pressure fall-off test, a pump test, or an injectivity test. Next, please. So operational controls required by the rule. The permit establishes maximum injection volumes and pressures to assure that fractures are not initiated in the confining zone. The injected fluids do not migrate into any underground source of drinking water, and that formation fluids are not displaced into any underground source of drinking water. Operators are required to install and use during workovers continuous recording devices to monitor injection pressure, rate, volume, and the pressure on the annulus between the tubing and the long stream casing, and the annulus fluid volume added. Operators are required to use and maintain continuous recording devices to monitor that pressure, rate, volume, and mass, and the temperature of that stream. They're also required to install alarms and automatic shutoff systems in the systems, or at the discretion of the director, downhole shutoff systems, check valves. All alarms are to be integrated with an automatic shutdown system to ensure immediate response to critical operating conditions. If that shutdown is triggered, the operator must immediately investigate and identify the cause. The operator finally must immediately cease injection, take all steps to determine whether there may have been a release of injected carbon dioxide or formation fluids, and notify the director within 24 hours. Next, please. So seismicity requirements within the rule. Seismicity is defined as the occurrence of frequency of earthquakes in a region. The operator is required to design and implement a site-specific seismic monitoring plan capable of detecting and characterizing induced seismicity. The design of that monitoring must be based on the potential risk of disturbing the confinement zone and endangering USDWs with the area of review that was determined during the site characterization phase. Injection operations can be modified by reducing permitted volumes of pressure up to and including the shut-in of the well. Operators are required to periodically review the testing and monitoring plan to incorporate the monitoring data. And then after a review of the testing and monitoring plan, it should occur 2 years after injection begins, and that review cannot happen beyond 4 years. Based on the review, the operator shall submit an amended testing and monitoring plan or demonstrate to the director no amendments of testing and monitoring is needed. So next, please. That is the end of my testimony.
Mr. Eales, have you prepared to move through your demonstrative exhibit to summarize your rebuttal testimony?
Yes.
Please proceed.
Next, please. So in response to recommendations from CBD, some were existing siting and corrective action standards as recommendations that were including prescribing broader non-physical well review and public space siting setbacks. These were calling out the potential of not being able to find a record of a well in the system and how there should be a greater prescriptive nature to spell out how to do that. The response to that is that the OCD online system is very robust, but even beyond that, that the operator has the obligation and the requirement within the rule to ensure that they have identified all wells through whatever means they need to find. It is their obligation and their expectation to find that. Therefore, it's not necessary, in my mind, my opinion, to add any further prescriptive means of doing that because it is specified as a pre-construction requirement. The other one was adding specific well plugging language within the area view, which is similar to that point as well. And both of them touched a bit, or one touched more on the setbacks and one more on the availability of data. In my opinion, public setbacks don't directly bear on containment or USDW protection. And the existing AOR rules that I talked about earlier already authorize site-specific plugging, remediation, and other corrective actions. So recommend not addressing those or accepting those. So next. Another is recommendation for sonic and porosity measurements within the logging tools. And I found those to be acceptable. Those are good tools to use. They were presented earlier in other demonstrations and witness. So that is a recommendation I would accept. Another one was recommending best available technology. And unfortunately, that one I see as an unintended consequence possibility in which best available technology could be something that's in experimental mode still and not something that's proven technology, which could prescriptively tighten up something that's not really been proven again. So I recommend not doing that. Another one was a mandatory 5-day ramp up. Again, that could have those unintended consequences, and it's much better to allow each of the permits to be specific to the needs rather than all permits seeing a 5-day ramp up in injection. The other one is annual noise logs, and it was requiring an annual noise log at a high frequency. In order to perform those noise logs, it would require shutdown of operations at that frequency and would be disruptive to operations. Again, the language that's in the current proposed rule covers the ability to inspect and ensure that there's integrity on the wellbore through other means, and it does reference noise logs, just at a lesser frequency and something that's available if it's the right solution. So next, please. And then with this one, repeated resistivity logging, permanent borehole raise, and ambient noise tomography. Again, not something that's necessary to mandate, very similar to what I was saying earlier. Most logs actually do repeated resistivity as part of the suite that's incorporated with them, but it may not be the right tool. As was referenced earlier, the logging itself is its own speciality. It's its own technical solution. And so permanent borehole arrays, ambient noise tomography, those two actually push into seismic data gathering. And again, those are very prescriptive and kind of tighten you into a corner. The Bureau of Economic Geology for New Mexico does a very nice job of defining the terminology and what they expect from this experts in seismography. So to try to build this into OCD it would again restrict the operator as well as the BEG. Isotopic identification of the CO2 source. This was referenced earlier, and what I'll add is right now the rule does require surface CO2 monitoring to see if, and several points of monitoring CO2 to see if it's coming to surface or it's coming to water wells. You have the ability at that point to then go to isotopic identification. So it's still something that's available, but to go straight to isotopic would not be as valuable as what we're recommending in the rule. And again, access was recommended by CBD to begin doing background testing in the full round of the AOR prior to a permit being issued. The reality on the ground is area landowners and operators are not going to be very open to allowing everyone or sampling technicians to go on their sites prior to knowing there's a permit and prior to knowing that there's a reason to do it. So it's just a recommendation that we don't accept this, again, recommendation to begin before the permit is issued. There's plenty of time once the permit is issued before injection activity begins to do that background sampling while people know that there is a reason to ask for that access. And then emergency response training mandates that are specific. This was actually something I learned in doing the outreach sessions through the state. We had begun to do outreach telling the county commissioners, county emergency responders, how to respond to CO2 and how to respond to certain risks. And we heard very clearly in those outreach sessions from all the sheriff's deputies, community responders that that's what they do and they know how to do it well. And just please tell us what the risks are and give us your thoughts, but we will take it from here. So again, I think if we were to get too prescriptive in the draft rule or the final rule, I think it would slow down the progress of what we learned New Mexico already has the experience in and can incorporate the new risks associated with CO2. Next. So the Class 6 framework, we talked about caprock seal. This is the one I recommend to correct and accept the language that Dr. Schnarr said earlier to change it to the confinement zone. So the side on the right, the self-insurance, I recommend we retain self-insurance as an available financial responsibility mechanism. And the reason for that is self-insurance may equal or exceed third-party insurance protection for some large entities and financially stable entities. So by removing that, it may inadvertently reduce the ability of an entity to even more thoroughly and more robustly provide financial assurance. Next. So monthly casing inspection logs, although this is a great tool to determine whether casing is maintaining its integrity, performing a casing inspection log requires taking the tubing out of the wellbore entirely, which could take 2 weeks to do that. So every month you would have to remove the tubing over a 2-week period and then essentially put it back in after you logged in the next 2 weeks. So recommend not accepting this because there already are robust mechanical integrity testing methods in place that allow the tubing to stay in place. And if you have a concern that comes up through that suite of tools in which you identify a concern, at that point, you can always remove the tubing and run a casing inspection log. So this one, recommend not doing it. And then the seismic network, there was a recommendation that was specific to ownership of the seismometer. Again, the Bureau of Environmental Geology has its own system in place that doesn't require public or even state ownership of the seismometer. What it requires is a very robust ability to meet their expectations. They have a 2 or 3 page document that defines the quality of the seismometer placement and the means of getting it set up where it's communicating into the public system prior to your allowance to inject. And then finally, the threshold metrics that were spelled out also, the PGV and the PGA, these are very specific terminology tied to seismometers and seismic detection. So these are potential velocity and potential amplitude. And the thresholds can be very rigid. And again, this is something where the Bureau of Economic Geology is the group that regulates how New Mexico, doesn't regulate, but identifies the proper and the best technology for New Mexico for its seismic plan. So I recommend not accepting those. Next, please. One other recommendation was to report all malfunctions. And the term malfunction could mean about anything. So recommend not doing this. A malfunction within reporting could be that a reporting gauge or meter lost cellular communication for 30 seconds or 1 minute or some period of time where it's not damaging from an environmental or safety standpoint, but it could be considered malfunctioning. So the operator does have a requirement, as I spelled out earlier in my witness in my presentation, to ensure that they are monitoring all of those data points and ensure that those are recorded and reported. If those are not done, then they are in violation, they're in non-compliance. So don't recommend the word malfunction. And then on-site staffing, I referred to it earlier, and the rule also has a requirement for automatic shutdowns. Automatic shutdowns just refers to the robust systems that are in place now for monitoring and alarms, where there doesn't have to be someone sitting at the well, watching the well or near the well. The systems that are tied into control rooms, where operators can be at a safe distance from the well and from operating. And again, these systems will allow, and it's required by the rule, to shut in automatically. And so finally, a mandatory cessation trigger. This was recommended, and it's a good recommendation. However, it's already in the rule as drafted, and that is that the director has the authority to stop injection when necessary. So that's already in place, in my opinion. Next, please. And finally, the OCC proposals were a construction period to require the construction of the well to begin in 5 years, not 2 years. Recommend that we stay with the 2 years. It's a reasonable start when you have the technical information remaining current. 5 years, the technical information could change during that time period. So recommending to stay to the 2 years. Another recommendation was financial responsibility to retain net working capital for flexibility, or to remove net working capital, but I'm recommending we retain it there, and that's also a minimum requirement within the EPA federal rule, so striking that would make our rule less protective than the EPA. And then minor modifications, don't recommend that we add the undefined increased risk to USDWs. There was a recommendation that minor modification terminology could be used as long as it didn't increase the risk to USDWs. And again, it's very prescriptive, and we just stay with the site-specific framework. And then finally, surface casing logs to run spontaneous potential logs. If we were to remove that, as noted earlier, we would be less protective than the EPA minimum guidelines that are in place, so we recommend we keep that in place. And that is the end of my testimony.
Thank you, Madam Hearing Officer. We continue moving right along. We're done with Mr. Eales. I would, could we have a 5-minute break?
Terrific, thank you. Let's take 10 minutes. 2:10, please. We are back after a short break. Mr. Tremaine?
Madam Hearing Officer, if I might address a housekeeping question or proposal. So I haven't had the opportunity to address any of the parties online, but I have pulled the parties in the room. Given our pace of play today, I think we are going to be done with the direct and rebuttal testimony today. So I would propose, just looking at the time, that whenever we end, we leave the record open for a public comment at 4 o'clock, as you described, and reconvene at 9 o'clock tomorrow with the panels and begin cross tomorrow rather than beginning today. I think we're just ahead of where we expected to be. So for the other parties' benefit, as well as my witnesses, I think starting tomorrow would make more sense for the panel cross.
All right. Let me pause for a moment in the event there's anyone online who would object to that plan. Sounds like a good plan to me. Commissioners, any objections from the dais?
I like it.
Oh, he likes it. Okay. Thank you very much, Mr. Tremaine. That will be our plan.
Excellent. Thank you, Madam Hearing Officer. The OCD calls Dr. Hassan Khaniani.
Dr. Khaniani, would you please spell your first and last name?
My first name is Hassan. My last name is Khaniani, Khaniani.
Thank you. Do you swear or affirm to tell the truth?
Yes.
Thank you. Go ahead.
Dr. Khaniani, where are you employed?
I'm employed in New Mexico Tech.
Okay. And what is your title at New Mexico Tech?
I am Assistant Professor of Geophysics and also a research scientist in Petroleum Recovery Research Center.
Okay. And are you, as part of your duties at New Mexico Tech, are you working with New Mexico Institute of Mining and Technology to support OCD's application for Class 6 primacy?
Yes.
And today, are you testifying as a technical witness in support of the application for rulemaking?
Yes.
Okay. Thank you. Dr. Khaniani, did you prepare pre-filed direct written testimony for this case?
Yes.
I will show you. Share screen. All right. Is that marked as OCD exhibit number 8?
Yes.
And does that direct testimony require any corrections or changes today?
I think if this is the final version, I think there is no revision.
Okay, thank you. Will you adopt your pre-filed written direct testimony as your sworn direct testimony today?
Yes.
Okay. Also ask if you have prepared a resume outlining your experience and qualifications labeled as OCD exhibit number 9.
Yes.
Okay. Does that exhibit number 9 require any corrections or changes?
No.
Okay. Did you also prepare pre-filed written rebuttal testimony, which is labeled as OCD exhibit number 23?
Yes.
Okay. Does your rebuttal testimony require any corrections or changes?
No.
Okay. And do you adopt your pre-filed written rebuttal testimony as your sworn rebuttal testimony today?
Yes.
Thank you. Madam Hearing Officer, I would move admission of exhibits 8, 9, and 23.
All right, I'll pause for a moment in the event there are objections. Exhibits 8, 9, and 23 are admitted.
Thank you. Dr. Khaniani, have you prepared a demonstrative presentation to facilitate the summary of your direct testimony?
Yes.
Is that what I have shared on the screen here today?
Yes.
Okay, thank you. Dr. Khaniani, please provide the summary of your direct testimony for the commission, not to exceed 1 hour. Thank you.
Thank you. Hello, everyone. My name is Hassan Khaniani, and I'm going to support the testimony related to section 19.15, 41.7, 42.11, 43.7, 43.9. And those are related to injection zone, characteristic of fault, area of review characteristics, and decision making, and the injection zone property and characterization. Go to the next. So this is my professional background. I'm currently assistant professor of geophysics from New Mexico Tech. I have a joint appointment between Petroleum Recovery Research Center and Department of Mineral Engineering. My PhD is exploration geophysics from University of Calgary, bachelor and master degree in petroleum engineering. And I have experience in performing MRV plan, permitting technical support for Class 6 for subsurface. My role was subsurface modeling, seismic imaging, and inversion. I have been doing fault sleep potential. I'm going to explain about this terminology, geomechanics, and subsurface monitoring. Also, we develop in New Mexico Tech the sensor system, mostly based on the ultrasonic sensing system for tomography and imaging. That means that we also develop petrophysical well logging, reservoir monitoring, and we do research on underground hazardous environment sensing, such as distributed acoustic sensing and pillar imaging by ultrasonic waves. I have also teaching experience in machine learning and geoscience and engineering, geostatistics for subsurface modeling, and also rock mechanic. Then my relevant publication to this hearing is CO2 ER time-lapse monitoring, seismic inversion, and underground mine hazard modeling and decision making. Can you go to the next? Okay, and we need to, in order to understand what problem we are going to discuss, let me show you. In the right side, you see a well bore. We do injection into the subsurface. We have some confining zone that has low permeability, that if you inject your material into the storage zone, to the injection zone, you are expecting that the fluid and the gas content doesn't flow upward. Specifically, we are not interested to pollute the USDW. I mean, you don't want to make the water polluted. So the problem is inject CO2 into deep geological formation while protecting underground source of drinking water. Okay, and we have to deal with some risk issues. One is that if there is a fault or fracture in the region, you have to analyze that. We also need to understand the pressure that we inject the fluid, there will be pressure buildup. How this pressure buildup will affect the reservoir condition, and also if there is an existing fault, how this pressure will affect. Okay, does it create a fault activation? Maybe there is existing fault. Does it make a fault reactivation? If there is no fault, does it create any new fracture? So also we need to understand, as you can see on the red color, it's called plume, and you want to understand how the plume volume and also pressure front migrate from the injection well. You want to understand that, and so that is what we discuss next. Okay, so we want so in general performing like a class 6 well or class 2 or whatever similar injection scenario we have like a large team of experts. It's not just geophysicists, it's not just rock mechanic people, it's also it needs survey, it needs well design, it needs drilling, also you need reservoir engineers, geologists specifically. They play important role, and all of them combine a lot of data sets to make a good plan, a good understanding of the subsurface. Go to the next, please. So here is a scenario. I just want to define what are the definitions. So we have, let's say we have CO2 plume, and you want to understand at the beginning, and you want to have some estimate, and you want to evaluate your reservoir condition and see how much your front, and as you can see in the red dotted line on the right side, you can see that that is how much of your underground environment are affected by the injection of your fluid. That is called, I mean, you have to understand that, and you want to evaluate that for your area of review. So that is one of the most factor in understanding this. Also, you want to see in during the time and when you will reach to the fault, existing fault in the model, and then how you want to write your scenario to define that if your pressure front or plume front hit the fault. What type of fault is that? And you want to understand those type of, you have lots of questions, and you want to be as realistic as possible, and you want to mitigate your risk. Why? Because when you reach your fault, if your fault for any reason during the geological time become transmissive, which means that it can carry the fluid. I mean, in the next slide, I discussed about transmissive fault. But when you reach to the fault, you want to ensure that it doesn't reach to the USW, I mean, your fresh water, okay? So, what we want to understand again, geology and structure, that is very important. Because sometimes you are close to the fault, but your structure is on the way that you have anticline or other structure that the fault doesn't create a problem. So we need to have an understanding of a subsurface. We need also to have a good understanding of porosity and permeability of your injection zone and your confining zone, okay, your seals. And then you need also to understand and evaluate the geomechanical property of the fault, okay? I will discuss that in the next few slides, which is called fault slip potential, okay? And fault slip potential is understanding your regional stress. You want to evaluate your fault, okay? So key risk to be evaluated is if the fault or fracture are transmissive, your pressure buildup, does it create new fault or new fracture, or which is important because you don't want the fresh water USW be affected, okay? Go to the next slide. So I also want to discuss about how we find the structure of subsurface. Usually, one of the main the method is using the surface seismic data, and it's also called active source. Active source means that, for example, in the right side you have a Weber size, and it has a controlled source. It sends the wave energy onto underground, and it reflects back on different layers by the sensor, as you can see on the receivers. So the receive wave are analyzed using back propagation of the wave and analyzing like different imaging techniques. So you can have the structure of subsurface. And one of the advantages of this method, the seismic, is that you can have like a big picture of your model. And so I want to also mention that there are several layers in subsurface because of the different geological deposition, and that creates different elastic property. Elastic properties such as velocity, density, shear velocity, those are different for each layer. That create a different echo of the wave or reflection. and we are analyzing that. And so what happens if we inject fluid? Then injection fluid also affect our elastic property. So that's why several times the seismic can be repeated, and you can evaluate like how your plume movement is during the time. It supports the structure interpretation and reservoir characterization, and you can have a good idea about your area of review, delineation, and long-term containment. You can use the seismic method as a very effective and basically the main tool for modeling of your subsurface, okay? So basically, the seismic method are used to create the model for reservoir simulation and other property we want to get from the seismic data. So, and this is not the only one. We are combining this seismic data with geological information from different well log data we have. We have the tops, and we construct the data from geology as well. And eventually we combine these two. We have like more certainty about the quality of the data and the model that you create for subsurface simulation of the reservoir. Can you go to the next slide? So here is several scenarios of fault, okay? The fault can be barrier. It can act as a barrier. It can also act as potential pathway to USDW, okay? Because if it is transmissive, then the fluid can move. When you inject the fluid, during the pressure difference, the fluid goes toward the pathway, and it can reach to the USDW. And it can also be a barrier. So the seismic data, because this change and contrast that you can see, the seismic data hits this, it also creates the contrast in different angle. So the seismic data can help you to identify location, orientation, geometry, and also how the faults are continuous and how they are extended on subsurface. And if you want to use that for geological reservoir simulation, you can use the seismic data. So the other data source, as I mentioned, one is using geologists. Also, we have well log data. We can do interpretation for regional structure, and that's how we develop our model. Can you go next? Okay, so far we have been discussing about the structure surrounding the injection zone. Here is the injection zone itself. We need to also understand the properties of injection zone and how the quality of the injection is. We use other source of information when available. For example, core data, laboratory testing, well log analysis, seismic survey. We can do inversion. We can get an extension of the elastic property on the reservoir injection zone, and regional well correlation, as we mentioned. And what information we can extract from them is porosity, permeability, and formation properties like thickness, confining zone, thickness as well. So next. Okay, so at this part, let's say we have a reservoir we are injecting now. We want to see how much of the pressure we can go, how much injection we can do. There are several factors that we need to study. One of them is that we need to study geomechanically on the region. So every region, there are in situ stress. This in situ stress are affected by several factors. For example, one is the tectonic, the regional. For example, in New Mexico, we have rifting, and we are separating of the layer. Between two Rio Grande, we are having separation. We have motion of the movement of the the surface, and it creates a tectonic called stress. And the other factor is the density of the overlaying rock. When you push layers together, then it pushes sideways, and it creates horizontal stresses as well. So we have vertical stress and also horizontal stress. We have other properties of reservoir. It's called fracture pressure. It means that how much pressure you can inject to the reservoir that doesn't create secondary fractures. And that secondary fracture can be dangerous because it can create leakage toward the water resource, or can be leakage to the other unwanted area, unwanted zone. So we need to also study rock strength, fault orientation, and also we are also performing reservoir simulation. That means that that means that how much CO2 plume that you inject in what direction it moves and how it moves and what is the pressure during the time. Okay, so the criteria is that the pressure should remain below levels that could compromise containment. It doesn't create leak or fracture, induce. It doesn't create fault slippage. I will explain in the next slide. And then it doesn't open like a closed fracture. It doesn't affect the properties of the existing fracture, and doesn't create migration pathway of the injection fluid. So go next slide, please. So here is about how fault slip potential means. Fault slip potential is the whole sequence of analytical and numerical method to evaluate your existing pressure on the pore space and on fault planes, and you want to evaluate what will be the next stress on the fault plane. If you see on number 1 here, we have in situ stress, as we mentioned, due to tectonic, due to the density, the overlaying density of rocks, and then you have minimum horizontal and maximum horizontal stresses. So let's say we have fault, and number 2, you have a fault, and you have this regional stress. You want to see how much stress on the plane of this fault are. So the number 1, and you have on number 1, you want to map them on the fault plane. You want to see how much shear stress you have as a result of the present, the current state of your fault. You want to see how much vertical stress on the plane you already have. And then you calculate your pore pressure. That pore pressure are done by reservoir simulation. You can calculate that, and then you will see how opening you can open this fracture. When you open that, then basically you are reducing the effective stress. That means that if two faults are on each other, if you reduce the stress on each other, they can slide easier. That is the principle of fault slip. Potential, the potential that the fault can slip, perform a slippage. On the right side, we show you an example of a fault plane. It's in the 3D space. In the middle is an AGI well, and we have like a two fault on the side, and we can calculate what is the minimum stress needed to create the activation of the fault. Okay. And if you have that value, then you have the reservoir simulation. You calculate the reservoir pressure, and this is below or above the safety factor. So everything we can calculate based on the physics existed. And here, as a figure on the right bottom, you can see it's called Moore diagram. As you can see, all of the fault system are below a red line. The red line is the criteria for safety. So if we want to define a criteria for safety, there is a science, and each site has a specific factor for itself. This red line is different. Okay, so we need to specify that for any reservoir. How do you want this fault be? Okay, there is no universal value for all of this fault. Each fault has its own property. Each region has its own characteristic. Next slide, please. Okay, so that's that becomes a ground for my rebuttal. There we go.
Thank you, Dr. Khaniani. As we stop there, is there anything anything that you need to add to your summary of your direct? Otherwise, we can move right on. Okay. I will keep the slide up. Dr. Khaniani, please provide a summary of your rebuttal testimony.
Okay, thank you. So, based on what we mentioned in my testimony, I would like to mention that we have been reviewing the technical sections, and I have some consideration for rebuttal, and I want to discuss that. But I want to say that most of the comment I have is based on, it should be based on project-specific geology, geomechanic, monitoring, and modeling, implementing the physics. Okay, so because we need to study the fault, fracture, injection zone property, pressure responses, plume and pressure front behavior, as we showed, and we have to discuss that based on the site specific. So we cannot have like a fixed statewide requirement for each class 6 well. You have to give the option to the director, OCD, and to require additional safety guard if needed. Go ahead, next. So the first one, for example, is the Center for Biological Diversity suggestion regarding mandatory 5-day ramp-up period and universal spinner log requirement. I think previous testimony already discussed about the 5-day ramp-up. But in my opinion, a mandatory 5-day ramp-up period and universal spinner log requirement are unnecessary for a statewide Class 6 program. This operational measure should be based on site-specific factors, including fracture pressure, geomechanical condition, confining zone integrity, and fracture characterization, reservoir pressure response, and monitoring data. The division should retain discretion to acquire a staged ramp-up spinner log, lower injection pressure limit, or other measure were warranted. But imposing them on every class well is not technically necessary and may not meaningfully improve USDW. Here are examples of alternative method. Okay, so for example, you can use pressure rate monitoring, pressure fall-off test that already has been mandated, temperature log, noise log. You can use distributed temperature sensing, distributed acoustic sensing. Maybe some of the well already have this information. We should give this option to the director to make the decision if a spinner log, because a spinner log is based on the rotation sensor in the well, and it can change when there is a leakage. But there are other methods that you can detect the same, maybe in each well log, and well, the situation is different. Next. CBD proposal to reduce the maximum injection pressure limit from 90% to 80% of fracture pressure. Okay, so as we discussed about fracture pressure, I think the EPA limit of 90% fracture limit is technically appropriate. Let's keep it. And remains below the fracture pressure and includes 10% margin already. We have it. Class 6 has multiple safeguards. We perform geomechanical evaluation, continuous pressure and injection monitoring, mechanical integrity testing, pressure follow-up testing, AOR modeling, and re-evaluation. And also we have director authority to require lower specific pressure. So if needed, we have to evaluate the reservoir, and then we should give the authority to the director to make this decision. So if they want to make 80% limit or even lower, that is not a standard. So putting a universal 80% limit is not technically necessary for every project. So there was like an example of Redbird number 4. It was a class 2 solvable disposal case, not the class 6 storage. It is important. It reinforces the importance of monitoring, but it doesn't necessarily give the conclusion that 80% is necessary for I think 80% of the fracture pressure is necessary for all the class well. So it's not, it should not be mandated, in my opinion. Next. There are some addition to the mechanical integrity requirement. For example, it was asked to have like alternative noise method. So noise method basically means that if there is like a leakage, then the noise can detect where the fluid leaves or enters the well. And that is important for checking that the fluid doesn't move toward the USWDW. So it can be effective, okay? But they are not always the best method for external mechanical integrity. Effectiveness depends on flow rate, acoustic contrast, background noise, well design, casing, and cement condition. So they are different for each well. Other method may be equal or more appropriate. For example, temperature log, tracer survey, cement evaluation, pressure test, or other direct approve method. So our recommendation is to keep it perform-based, allow the director to select the best method for each well. So we shouldn't put noise method as a check of the integrity. Although it can be effective, but in some wells it cannot be. Next. The same for the tomography, noise tomography, ambient noise tomography, or Hall plots. We have been reviewing Hall plot analysis. Ambient noise can be useful, okay, but they should not be mandatory for class 6. Their value depends on site-specific geology, monitoring design, data quality, reservoir condition, and project objective. Hall plot analysis is basically the plot of pressure versus cumulative pressure versus time, and you want to evaluate their slope. And if the slope of pressure is high, it means that the injection is difficult. You have problem with the near well bore trend, okay? Or maybe there is you have less slope, then you have some stimulation response. So, but they are mostly related to near well bore analysis. You measure the pressure based on the near well bore. So it's not direct method for tracking CO2 plume migration or the extent of the plume or pressure front. So we should not replace pressure monitoring. So we already have pressure monitoring, pressure fall off method testing, plume modeling, or geophysical monitoring. Those are already in the mandating procedure. So, but this one should not replace those approach. So these type of data, like injection pressure, already are collected in class 6 operational monitoring. So ambient noise tomography and Hall plot should be used when they provide meaningful technical value rather than required as mandatory statewide monitoring method. Next. Conservation group addition to the area of review and corrective action. So here we have third-party verification and modeling ensemble. So we can have mandatory third-party verification, but it raises practical issues. Some of the issues is that, so if you want to, for example, I do the evaluation and somebody else does another evaluation with the fault, and I evaluate the fault with with transmissibility, and somebody else says, no, this fault is not transmissible. So it raises another issue that the reviewers, the person, the third party that reviews, they have to have qualification, and they have their own standards. And so at the end, when we don't agree on our standard, then we have to go to another third party to resolve the disagreement, okay? So it will be a big problem. So we know that OECD and EPA already conduct technical permit review, and public notice or comment already allow outside technical review. Better approach requires a transparent record with model software. We want to give more information. As you can see on the right side, I put some example of assumption and input. For example, modeling approach software we use, site characterization data, geological framework, model assumption, input parameter that we use, reservoir pressure, regime, formation, compressibility, a lot of factors. We provide that to the public instead of asking a third party come and verify the analysis. So do not require mandatory third party certification or a specific software. Focus on transparency so qualified third party can meaningfully review the modeling. So that is one of the challenges. Next one. Conservation group addition to the public notice requirement with an addition of third-party verification of modeling as example. We already discussed about that. Can we go to the next slide? Our reservoir simulation model inherently unreliable. In some part of the testimony, we observed this. I do not agree that reservoir simulation models are inherently unreliable. Model contain uncertainty. The data is uncertain. Every measurement we make contain uncertainty, but doesn't mean they are unsuitable or unreliable. Class 6 models are built from site-specific data. So it's like you have well log data, seismic data, core, lab measurement, pressure and fluid data. You already take sample from the well, and you measure porosity and permeability from some of the well. You perform geomechanical properties, and you obtain that data. And so the model that we create, especially for class 6, they are evolved during the time by calibration of the sample that you take and your reservoir simulation. Okay, they have this process, so they perform sensitivity analysis. For example, if my porosity, how much that creates an error to my output. So those solutions the reservoir engineers already have in place. So general class 6 modeling is not a one-time prediction. It is evolving during the time, okay? So you update your model and monitor process. That is mandated. Field monitoring data are used to compare prediction with actual performance. And so that is like they perform the calibration. So what is the recommendation? Use reservoir simulation model as reliable engineering tool when supported by site-specific data monitoring and periodic AOR reevaluation. During the time you reevaluate your AOR. Next, please. That's it.
Resolve your slides. Is there anything else that you feel necessary to provide in summary or rebuttal?
No.
That resolves Dr. Khaniani.
Thank you very much, Dr. Khaniani.
Madam Hearing Officer, OCD would call our last witness, Ms. Jennifer Raney.
Sorry, would you spell your first and last name, please?
JENNIFERRANEY.
Do you swear or affirm to tell the truth?
Yes.
Thank you. Go ahead.
Good afternoon, Ms. Raney. Where do you work and what is the title of your position?
I work at the Petroleum Recovery Research Center at New Mexico Tech, and my position is Deputy Director of the PRRC.
Okay. And as part of that role, are you supporting the Oil Conservation Division's development and application for Class 6 rule and Class 6 primacy?
Yes.
Okay. And are you testifying today on behalf of the Oil Conservation Division as a technical witness?
Yes.
Okay. Have you provided or prepared pre-filed written direct testimony, which we have labeled OCD Exhibit number 14?
Yes.
Okay. Does that testimony require any changes or corrections today?
No.
And are you prepared to adopt your pre-filed written direct testimony as your sworn direct testimony today?
Yes.
Okay. Have you also prepared a resume outlining your qualifications and experience in OCD Exhibit number 15?
Yes.
And does this exhibit require any corrections or changes today?
No.
Okay. I have three other ones that I'd like to ask you about. Ms. Raney, I'm going to point you to OCD Exhibit number 18. This one is EPA guidelines on community engagement for geologic sequestration project developers and Class 6 permit applicants. Sorry, I should say this is labeled as. Are you familiar with OCD Exhibit 18?
Yes.
Okay, and to your knowledge, is this a true and accurate copy of the guidance?
Yes.
Okay. And is Exhibit 18 one of the guidance documents relied upon by the tech and subcontractor team in development of the rules?
Yes.
Okay. Same questions for Exhibit number 19 here. This is labeled as the World Research Institute Community Engagement Guidelines. Are you familiar with this document?
Yes.
And is this a document that the New Mexico Tech team relied upon in helping to prepare these rules and community engagement?
Yes.
And to your knowledge, is this a true and accurate copy of the engagement, of the document, of the source document?
Yes.
Thank you. All right. And last, I want to ask you about OCD Exhibit 20, which I have shared on the screen again. This is labeled as the Interstate Oil and Gas Compact Commission Model Statute. Are you familiar with this record?
Yes.
Okay, and again, is this a record which the New Mexico Tech team relied upon in helping to prepare the draft rules? And
Yes.
and is this a true and accurate copy of the model statute?
Yes.
Okay, thank you. Madam Hearing Officer, I would move admission of exhibits, OCD Exhibit 14, 15, 18, 19, and 20.
Thank you. I'll pause in the event another party has objections. Exhibits 14, 15, and 18 through 20 are admitted.
Ms. Raney, have you prepared demonstrative slides to facilitate the presentation of your summary of your direct testimony today?
Yes.
Okay. I'm going to share screen. Is this your demonstrative?
Yes.
Good. All right. At this time, Ms. Raney, I would ask you to proceed with providing the summary of your direct testimony for the commission.
Absolutely, thank you. So for some of my qualifications, I obtained my Master of Science in Environmental Science and Engineering at the University of Kansas. I got my undergraduate, my Bachelor of Science in Environmental Science at Tulane University. I worked over the last 16 years on Class 6 permitting or CO2 sequestration projects in some capacity, primarily with the Department of Energy grants. The purpose of my testimony today is to demonstrate that the required public outreach and community engagement was conducted during the development of the proposed rules. OCD has made it clear that public engagement and public participation was a priority throughout this process. So OCD committed to go above and beyond the standard requirements issued by the US EPA at this time with Class 6 regulations. The rule publication and public comment period was done with a lot of thought and intention behind it. It was over a 2-year process. A lot of activity happened prior to releasing the draft regulations and crosswalk, working with interested parties, ones who might be advocates or maybe have concerns about the proposed rules. So to the best of their ability, they made sure to introduce these concepts to those parties and receive public comment. Back in August of 2025, the New Mexico OCD released the draft regulations and crosswalk for public review and solicited formal public comment. This was released with over a 30-day required public notice period, and all comments were sent directly to MNERD. Also, in addition to this, informational sessions and workshops occurred after that. Registrations were always published to the New Mexico OCD announcements page, which are commonly known, but also emails were sent out directly to relevant listservs of interested parties and also shared via social media on New Mexico Tech's LinkedIn page and other opportunities. At all of these sessions, translators were made available where the respective local language was spoken. Tribal consultation was a key element. We are in New Mexico with a very diverse population, and so tribal consultation was once again an instance where New Mexico exceeded the obligations with the effort that was given to contact the 23 tribal nations that are present in New Mexico. Informational letters were sent out to the heads of government for each of those tribal nations, informing them of the intent in New Mexico to obtain Class 6 primacy, and also making ourselves available and establishing points of contact should there be any questions from each sovereign nation about their own interest or relevance to the program. We met with the director of the Navajo Nation EPA, as well as the UIC director for the Navajo Nation on 2 separate times in Window Rock to make ourselves known, to introduce the concept of what we're doing in the program, and also as a public entity, share any lessons learned and information that might be useful to their governments. Briefing occurred with the Hickory Apache Tribal Council as well as their president to describe the status of our program and once again inform them of any interest that might be useful to their parties that could have questions on it, and also make any of our documents, any of our lessons learned available to them. Both of those were successful, and they did show their support, especially the Navajo Nation, which submitted a letter of support and comments in the public comment section of the report. There were also a number of focused feedback sessions to make sure that we were communicating closely and curating a narrative that was unique to each given sector. So for instance, Namoga and IPA&M are more industry focused, and so they will have more technical content that will be relevant to their sessions. And so those focused feedback sessions were really informative to how we analyze the draft rule and what changes or proposed changes might be included. Also, the sister organizations at the state office with the state land office and other entities, they were contacted and shared information throughout the process. Environmental NGO meetings were also very useful and informative, sharing what a variety of stakeholders, what questions might come up, and very unique considerations that might not have been addressed before. A lot of that was carefully summarized and analyzed in group meetings, which I will get to. Next slide, please. To guide this process, as I have in the exhibits I've listed, the US EPA has drafted a number of incredibly useful and detailed guidance documents, particularly some catered to community engagement and public outreach. These are developed over many years of lessons learned and best practices, both within the states that have already obtained primacy, but also from CCS projects from around the world and here in the United States. So all of these lessons learned are built into these programs and formulating these best practices, which we'd like to follow. This here is a diagram that's extracted from one of those guidance documents. It follows a pretty standard procedure, which needs to be unique to each prospective site. So to begin with, you would identify your decisions for input. What considerations do the decision makers need to take before proceeding, whether or not a project may or may not occur? Next, you would like to identify or analyze the communities that would be included. In this consideration, you want to make sure that you're contacting any parties or communities that would be most impacted by a potential site. And also with these requirements, you want to ensure that meaningful participation occurs with those affected populations within the decision-making process. An example of this is doing a social characterization analysis, where you would survey government websites, any publicly available information, county assessors, to identify taxpayers within the area of review, identifying all those community members and taking into consideration what are their preferences, what are their standard operating procedures, how to communicate, that all comes into play. So first, identifying who those community members are. Next, you would go on and identify the message or the narrative that you would want to convey to those community members. A critical component of this is also getting the right messenger in place. Taking this dense technical information and converting it into something that is digestible and easy to understand is an essential way to make sure that meaningful participation occurs. The information that is provided to those community members needs to be digestible and easy to understand. Typically, you want to find a messenger who is local to that community and knows that community through and through. So ideally a local and somebody who has grown up or lives in that vicinity of that prospective project. Next, you would select the engagement method that would be important for that community. New Mexico is a largely rural state, so having one instance of a public town hall might not be sufficient to reach all the community members. You also might have a lot of elderly populations that aren't as familiar with electronic email, so you would try to do more of a spoken word approach or going door to door. So you really need to curate your messaging and your engagement for the populations that you've identified. And next in that process, you need to prepare the materials specific to that population. If, for instance, you're talking to a group of industry professionals, using more technical information, using those scientific terms that they're already familiar with, that would be appropriate. That would convey the level of interest and information that would be necessary to understand the proposed project. However, if you have somebody who's completely unfamiliar with geology or concepts and doesn't have a scientific background, addressing the information in a way that is more familiar to them is going to be important. Again, a key component in this very diverse state, we want to ensure that the communication methods are using the local languages that are relevant to that population. So in the instance of what we did in our outreach, we ensured that we had potentially a Spanish translator or somebody who was a native Dene or Navajo language speaker present and available at all these communication events. Next, you would implement the engagement. This is going to happen prior to the application, during the application process, and if successful, throughout the lifetime of the entire project. This needs to be documented and done effectively and with an approved engagement plan that would be approved by the director. Throughout this process, you would evaluate the success of that and solicit feedback from the affected parties, making sure to document that and possibly make adjustments wherever needed if there's meaningful feedback that could improve the whole process. Again, this whole engagement process is ongoing and will occur throughout the lifetime and after cessation of injection and post-injection happens. And this is all taken into the decision-making process. Next slide, please. So in order to demonstrate an example of how this would occur for a potential site, the OCD and the team decided to emulate what would happen for a proposed project, giving some examples and highlighting what community members might expect if a proposed project were to happen or be presented in their area. We formulated a workshop and informational sessions that would provide the kind of information or input that they would see at a proposed activity. As you can see from this map, we covered most of the state. In doing our initial assessment and background knowledge over 20 years of doing CCS research at New Mexico Tech, we were already well aware of where Class 6 projects were likely to occur given the local geology, which would namely be up in the San Juan Basin, up in the northwest, and then down in the southeast in the Permian basins. However, we also wanted to address the higher population centers, looking at Albuquerque and Santa Fe. These events began early on prior to actually completing the draft rule. The OCD conducted informational sessions in Santa Fe. These were offered in person and also hybrid for those who couldn't make it in person. They were very well attended by a number of different ENGO groups that provided very good input, had very specific questions, and really formulated our decision-making and how we went about the process. Next, we moved on to Farmington up in the San Juan Basin, which is more likely where Class 6 projects would occur. And going back to how you have messengers and messaging and curating that specific to the population, we worked with local academic institution in San Juan College, which actually trains and employs a lot of the local workforce, and we used messengers people were familiar with at that time. We then went down to Carlsbad, where industry professionals are more present, but used a New Mexico Tech facility, which is a public facility that people were familiar with the National Cave and Karst Research Institute. Then in Albuquerque, there was another workshop where a number of different groups were there for conferences, so we made sure to hit all of the energy sectors that might have some questions or might be unfamiliar with it. Hobbs was our next location down in the southeast, and that was held at New Mexico Junior College, which is also a well-known entity as a junior college. They train a lot of the workforce that would conduct any elements of the emergency response, any kind of monitoring or testing that might occur in that area. So there was some familiarity with it, but they also helped distribute and advertise the word of those workshops being available. Then notably, we worked with the Hickory Apache Tribal Council up in their building. We spent about a half a day with them, working with the entire tribal council and their president, talking about the potential opportunities. There were a lot of unique, specific questions on the geology where they lie, but luckily we had the background that we were able to answer a lot of those questions, and there's been some follow-up discussion since. So it was a very useful model, and this is supposed to emulate what would happen in a local site if an interested party did have a prospective permit. They would have to go and engage in a similar manner where you would identify local public institutions, key stakeholders, and find the interested parties and present this information in a neutral platform, potentially in a public institution or academic institution that you see that we identified here. Next slide, please. So as we said, and EPA has outlined in their best practices document, effective engagement means translating information in a way that is useful and catered to the actual population and ensuring that you're identifying any potentially affected parties. Opportunities or ways that you could engage would include public or town hall meetings, holding open houses and informational sessions, and working meetings or focus groups with more specific backgrounds, ones who have more of a technical background or might be more academic in nature. If a site were closer to actually implementing or constructing a well, you could conduct a site visit or do tours of the respective facilities. But ensuring that you're doing targeted engagement and presenting material that is relevant to each different party is going to be critical. Local interest groups might be more particularly interested in the safety and the quality of the groundwater resources that are there, or maybe the native wildlife. You might also have economic development boards that are more interested in the workforce opportunities or the employment or jobs that might be associated, or potentially preventing any job losses. Again, technical groups might want to know what they can do in their own businesses to adhere to this, or what kind of policies or regulations might apply to them. Translation services should always be available, especially when we're talking about disproportionately impacted communities. And this is something that we did with all of our workshops and informational sessions. Anything that's distributed to anyone with a non-technical background should use non-technical language. As part of New Mexico Tech, and our previous witnesses have shown, education is our background, and so catering to all audience is something we do naturally. So making sure that communities and professionals who are conducting this and using them as messengers, they use that language that is appropriate for the groups. Over on the right, I highlighted some of the photos of our workshops, what they should look like, what you would expect if you're a community member, what you might see. What we did is we had some of our engineers and our geologists go out into the field and talk with community members, talk with first responders, and also the local academic institutions, showing them what this technical information actually means and the nuts and bolts of it. What does the simulation actually entail? What do you take? What geological data goes into that model to have that assurance and to make those predictive models and those assessments that this can be done safely and effectively without putting any risk to the USDWs. Also down at the bottom, you see that we contracted, or we worked with San Juan Community College School of Energy, who is already quite familiar with a lot of the groups who could implement this work and can use this language, and also talked about some of the curriculum that they have available to train the potential workforce, as well as the regulators within the state of New Mexico, to ensure that this program is administered safely and effectively. Next slide, please. In going throughout this process, you have a number of ways that you can distribute the information. Fact sheets are going to be one of the primary ways to introduce this, and especially in the written medium. I'll go into a little more detail on what is included as a fact sheet as an example within this program, but other methods that you could use would be television shows or television commercials, radio, daily newspapers. There are really a variety of platforms that can be utilized throughout this process. And again, it depends on the location in which you are trying to permit a project. In some instances, you might have more of a larger landowner where fewer community members are actually present or around the AOR. This is where direct communication might be more appropriate. Visits to their farm, visits to that the local community, and to sit down and talk face-to-face with them on a routine and continued basis. Printed advertising and press releases should be done on a routine basis and updated over time throughout the duration of this whole permitting process. In talking and identifying new messengers for this, news reporters could often be a good option for who can communicate the details of a project to the local community. Ensuring that the information of a project is taken and adapted and presented in a way that is easy to digest and understand is sometimes a challenge for some of the experts. News reporters typically have a background in communications, and they are effective at communicating with their local communities and also knowing what is important to those local communities. So that is an example. If you're not looking, let's say, at an academic institution or a professor or leadership, a news reporter has been shown to be effective at doing this. Social media tools are also very useful to get the word out to different demographics. More younger populations might have them, but you also need to consider that not everybody has an Instagram account or Facebook account. So expanding this to also looking at podcasts and webcasts that might be a little more accessible and transferable and also easy to share, because word of mouth can be very helpful in getting the word out as well. Considerations again in this whole process is that all information should be easy to understand using the local language. And while we did also require in New Mexico, the OCD, not only to mail notices out to individuals within the AOR in that region, but email as well, electronic communication. However, there are many instances where somebody might not have access to broadband, so addressing what those availabilities are and what is more effective to that individual is always part of the process. Next slide, please. So this is one example of the communication that is required through the program, which would be a fact sheet. Fact sheets have to be distributed and shared to any interested member of the public throughout any process. The director at any time will maintain a list of interested parties who want to be included on any updates. These fact sheets will be mailed out, but of course the priority will be that anybody within the AOR or in the region who wants information, the local community, they will have access to this fact sheet. The fact sheet itself is going to take information on what the injected material would be, what interested parties will be conducting this project, how long this will be, when public notice periods will be, how and when members of the public can enter into their comments and enter in any concerns. And with this whole process, identifying the individual that they can go to ask questions. Prior to doing this, the responsibility of the permittee or whoever is seeking the project, you want to ensure that there is consistency with the individuals that they can go contact. Any individual who is selected as the messenger or to answer questions needs to be providing a consistent, reliable message and be easy to identify. So making sure that you have a community member or a local stakeholder that is not going anywhere and will be there throughout the duration of the project is going to be key. 30 days notice is what is required in advance of any public meeting or public hearing. However, that is minimum. It could always be extended in the event that there might not be availability to any party. But the federal rule requires at least 30 days, and so the OCD has stuck to that language. In any case where there's more stringency that was suggested, the guidance typically might allow for more stringency. And so while New Mexico OCD has intended to have more stringency and more engagement and requirements with community outreach, in order to keep things more consistent with the federal rule, this is where we defaulted to language that was more familiar with EPA to alleviate some of the stringency evaluation concerns. And I believe that is my last slide is my example. The rest is supplement, yes. And that is it.
Ms. Raney, is there any material we have? I'm looking at. We're closing in on half an hour. If there's anything that you feel in additional materials that is appropriate to present, now is the time. Otherwise,
No.
that's it. Great. Okay. With that, Ms. Raney did not provide rebuttal testimony, so we, Madam Hearing Officer, we are done for the day.
All right, thank you, Ms. Raney and Mr. Tremaine. I had said during one of our pre-hearing conferences that I would call on folks for cross in the morning in reverse order, starting with industry and then coming back to the environmental protection groups. And I am putting in the first position in each case the parties that are actually presenting witnesses. So this is the order I'm planning, and you can comment if you'd like. OCC, NMOGA, conservation groups, CBD, Wild Earth Guardians, and then back to the division, if in the event you have redirect, obviously, and then to the commissioners. All right. Is there anything else we can do before we take a break ahead of the 4 o'clock public comment session?
Madam Hearing Officer, just to clarify expectations for everyone, we will present for cross-examination Dr. Sai Wong and Dr. Hassan Khaniani first. and then proceed to the other 4 witnesses as a panel whenever we're done with the first panel. But that's what we're preparing for in the morning.
Thank you so much, Mr. Tremaine. Anything else we can talk about before we take a break ahead of the 4 o'clock public comment session? No? All right. I'll be here at 4. See you in the morning. All right, we are back after a break following the end of the division's witnesses. It's 4 p.m., so we turn now to our first public comment session. This is an invitation to anyone in the room or on the platform who would like to offer non-technical public comment. There will be several other public comment opportunities from starting tomorrow. I'll issue the invitation at 9 o'clock each morning that we are proceeding into hearing. So let me ask if there's anyone in the room who is here to offer public comment. I think I recognize everyone in the room, so I don't see anyone. Sheila, is there anyone on the platform who would like to offer non-technical public comment? I see Allison Marks has raised her hand. Ms. Marks, I think you can unmute yourself.
Perfect. How's that?
Oh, terrific. You're coming through loud and clear. Would you spell your first and last name, please?
Sure. Allison, Allison, last name Marks, Marks.
Thank you. And do you swear or affirm to tell the truth?
I do.
Thank you. Go ahead.
Good afternoon, Madam Hearing Examiner and members of the Commission. My name is Allison Marks, and I serve as the Director of the Oil, Gas, and Minerals Division at the New Mexico State Land Office, and provide this comment on behalf of the SLO. I've been a licensed attorney in the state for over 20 years, devoting a significant portion of that time focusing on environmental and energy-related issues. At one point, I served as counsel to the OCD before becoming Deputy Director of that division. The SLO manages, for the benefit of 22 designated beneficiaries, with the biggest being common schools, 9 million acres of surface estate and 13 million acres of subsurface estate. The Bureau of Land Management, BLM, manages about 13.5 million acres of surface estate in the state, along with millions of acres of subsurface estate. The state receives 50% of all BLM royalties and of BLM lease sales. BLM certainly is an important agency for community engagement. In the history of my time working for the state, I have never seen a rulemaking where someone seeks to enact a partial rule or does not contemplate all necessary parts of a rule. In this case, the rulemaking seems to omit vital portions of the rule and defer those portions to a later time. SLO previously raised areas of concern regarding this rule, but in the interest of time, I'm going to address just a few. Also, while the BLM does not participate in state rulemakings, there were shared areas of concern between both the BLM and the SLO. For example, the rule is silent about carbon sequestration units. A sequestration unit should follow similar processes utilized by both agencies when forming an oil and gas unit. With such a process, the BLM and SLO, if fed state unit, or the respective agency if the unit does not encompass lands from both agencies, first gives preliminary approval, then obtains an order from the OCD approving the unit and any additional stipulations, and then obtains final approval. It is imperative to make clear in any rule that SLO or BLM cannot be forced into a unit. And while the SLO appreciates OCD's participation in the oil and gas unit process by approving units, OCD does not, based on representations from OCD personnel, enforce many portions of a unit agreement, even when that agreement is adopted as part of an order. Therefore, clear and specific guidance in the form of a rule must include clarity for permittees, state agencies, and other stakeholders. This rule fails to do so with respect to units, along with other key topics. Another matter of grave concern to the SLO is the failure to protect mineral owners and persons with the rights to extract minerals. Effectively, the rule fails to protect the beneficiaries and money the state obtains from mineral extraction, which is about 48% of the state's revenue, such as oil and gas, along with potential monies from other subsurface leasing, such as geothermal and helium leasing. The rule, pursuant to carbon sequestration legislation, notes that surface owners may own the pore space for sequestration, but the proposed rule fails to recognize crucial persons to whom notice must be given, such as persons who own the minerals, including government agencies, and persons who have leased such lands or otherwise have a right to extract minerals vis-a-vis contractual debt severances. Allowing for sequestration without sufficient notice could significantly increase drilling costs or pose additional risks companies may decide to avoid, This, in turn, decreases the royalty money this state relies on and raises the potential for mineral damage to a mineral owner or a lessee. Finally, the SLO believes it must be abundantly clear who has the liability to monitor or otherwise take care of a sequestration unit in the event an operator goes defunct or otherwise fails to address their liabilities. The SLO feels very strongly that the liability absolutely cannot be shifted to the beneficiaries of the state land office. The rule simply refers to, quote, the state, but this is unclear who the state is or if the reclamation fund would be used to address potential future problems. Thank you.
Thank you, Ms. Marks. Let me ask the commissioners if they have any questions of you. Yes, no?
For public comment?
Well, no, just in the event, because that was high level. You know what I mean?
Oh, no, not at the moment. I'm good, but thank you.
All right,
I
thank
appreciate the comment.
All right.
Thank you.
Thank you, Ms. Marks. Is there anyone else on the platform who has a question, has a statement as part of non-technical public comment? There will be other opportunities. This is your opportunity today. Anyone else at all, please raise your hand or reach out to Ms. Apodaca through the chat. No? Okay, in that case, we will see you tomorrow morning at 9, and we'll begin with the cross-examination of Dr. Khaniani and Dr. Wong. Thank you.